This video is going to have a look at the measures of spread that we calculate when we are analyzing data or a data set. So by the end of the video, you will be able to calculate what is the range of a data set. You'll be able to calculate the quartile 1 and quartile 3 within the data set, and you'll be able to calculate the interquartile range of the data set. So they're the three calculations that you'll be able to do by the end of the video. So when we're looking at measures of spread, what we are looking at is how far apart or how close together our data is. So data that is close together is going to be more consistent, and data that is spread out over a large range is going to be less consistent. So if you think about playing sport, you want your team's score to be very close together over 24 games in a season. Means you are being consistent every time you go out and play. If your scores are not close together and spread out, that means some weeks you go out and play really well, other weeks you go and play less well, and your team is not consistent. So range and interquartile range helps you measure the consistency of the data. Is it all close together or is it spread apart? So looking at range, which is the first calculation we do for measures of spread. So range is the simplest measure of spread that we use, and it is basically the difference between the smallest value and the largest value. So range is equal to the largest value minus the smallest value. So that is the formula that you need to use when you are calculating range. Range can be useful, but it can also be limited. So for example, if you have extreme values or outliers in your data set, your range may not be reflective of the actual spread. So if you've got one really large value, your range is going to be large. But the large range might only be caused by one value, and all the other values are consistent and close together. So it's not always a good reflection of the spread, but it's the measure that we normally start with in calculating when we're looking at measures of spread. In addition to looking at the range, we can also split our data set into quartiles. So when we split it into quartiles, and we should know that quartile equals 4, means we're spreading our data set into 4. So starting off with the lowest and the highest values, we can split our data set into half, and halfway we know from our measures of central tendency is going to be the median. So the first 50% of the data is between the lowest number and the median, and the second 50% of data is in between the median and the highest number. So once I've split it into half, I can then go ahead and split each half into halves again. So between the lowest number and the median, I'm going to have my first quartile, and between the median and my highest number, I'm going to have my third quartile. So now I've got my lowest number, quartile 1, median, quartile 3, and highest number. And in between each of those is going to be 25% of our data, or a quarter of our data. So between the lowest number and quartile 1 is going to be 25% of my data. Between quartile 1 and my median value, which can also be seen as quartile 2, is going to be another 25% of the data. Between median and quartile 3 is going to be 25% of my data. And then between quartile 3 and the highest number is going to be my last 25% of the data. So there are my quartiles that I can calculate to split my data into 4 equal sections, all containing the same number of values. So we can use our quartiles then to be able to calculate our interquartile range. Our interquartile range is quartile 3 minus quartile 1, and it gives us an indication of the spread of the middle 50% of the data. So what interquartile range is measures the consistency of the middle 50%. So around the center of the data, how consistent is our information? Is it all close together or is it spread out? Interquartile range will be a useful measure if there is one or more outliers, because it excludes the top 50% and the bottom 50% of the data. So it's only looking at the middle 50%, so any outliers that are present are excluded from this calculation. So if you do have an outlier in your data set, interquartile range is the better measure to determine how far spread the data is. So going back and looking at our quartiles, if you're looking between the largest number and the highest number, so we're looking at 100% of our values, we are calculating the range. If we're looking at interquartile range, we are only calculating the middle 50%. So let's have a look at the steps required to be able to calculate the interquartile range. Now the first step is to calculate the numbers in ascending order. Now if you've already calculated the median in a previous calculation, this will already be done for you. Once you have the numbers in ascending order, you split the data set into two halves, and it's got to be two equal halves. Then after you've split each data set into the halves, you calculate the median of each half, or you calculate the quartile values. So it's a similar process to be able to calculate the median, but this time you're ignoring half the data and either focusing on the first half or the second half. So you use the formula the same as the median, so n plus 1 divided by 2, but this time n is going to be the number of numbers in each half, not the total number of numbers. So you will see that when we have a look at an example in a moment. Step 3, once you've located your quartile term, you could go and locate quartile 1, then you go and locate quartile 3, and then you calculate the interquartile range by subtracting quartile 1 from quartile 3. So they're the 5 steps to calculate the interquartile range. Remember, you've got to split the data set into two halves before you can calculate the interquartile range. So let's have a look at an example. In the first example, we want to calculate the range and interquartile range for the following data. So we'll start off looking at interquartile range, and we want to arrange the numbers into ascending order. So we will arrange our numbers into ascending order. Remember, you can do a quick check how many numbers you've got after you've done it in ascending order. How many numbers did you start with? Make sure you've still got the same number of numbers. So I've arranged my numbers in ascending order. Now I've got to split my data set into two halves. So the easiest way to split the data set into two halves is to calculate the middle term or the median term. So all up in my data set, I have got 14 numbers. So 14 plus 1 is 15. 15 divided by 2 is 7.5. So my middle, where I can split my data set into two halves, is going to be in between my 7th term and my 8th term. So if I go ahead and count from the beginning till I get to my 7th term, then I can draw a line down, and that is going to split my data set into two halves. So my first half, I'm going to have 7 numbers. In my second half, I'm going to have 7 numbers again. So now that I've split my data set into two halves, what I can do is find the quartile terms or the median of each half. So going back to my n plus 1 formula, but this time I'm looking at the number of numbers I have in each half, which is 7. So 7 plus 1 divided by 2. So I'm looking for my 4th term. So in each half, the 4th term is going to be my quartile values. So going in now, locating quartile 1 and starting from the beginning, 1, 2, 3, 4. My 4th number is going to be 20. So my quartile 1 value is 20. Now to locate my quartile 3 value, what I do is I start in my second half and I start at 1 again. So it's going to be 1, 2, 3, 4. So my 4th value in my second half is going to be 32. So my quartile 3 value is 32. So now I go ahead and calculate my interquartile range. So quartile 3 minus quartile 1. So 32 minus 20 is equal to 12. So that's an example of how I can calculate interquartile range. If I wanted to calculate the range is equal to the largest value minus the smallest value. So 41 minus 12, which is equal to 29. So let's have a look at a second example for calculating the interquartile range. And this time I want to calculate just the interquartile range for the data set in the question. So I'm going to start off by arranging the numbers into ascending order. So once I've arranged the numbers into ascending order, I want to split my data set into two even halves. So all up, I've got 19 numbers. So 19 plus 1 divided by 2 is 10. So my middle of my data set is going to be my 10th term. This time, it's not going to be in between two numbers. It is going to be an actual number in my data set. So starting at the beginning, I can count till I get to my 10th term, and my 10th term is going to be 34. So when I'm calculating my quartiles and the middle of my data set is an actual term in the data set, I exclude that term. So I cross it out, doesn't factor into my calculations anymore when I'm calculating my quartiles. So that means I now have 9 numbers in my first half. I've got 9 numbers in my second half. So I'm still going to have 2 even halves, and my middle number just gets excluded. So now I can calculate the quartile terms. So finding out where in the first half is going to be my quartile 1 value. So using the formula of n plus 1 divided by 2. So I've got 9 numbers in each half. So 9 plus 1 divided by 2. So I'm going to look for my 5th term. So looking for my 5th term, starting at the beginning, counting to I get to number 5. So my quartile 1 value is going to be 22. Then again, starting at the beginning of my second half, and then counting until I get to my 5th term again. My 5th term this time is 56. So my quartile 3 value is going to be 56. So now I can calculate my interquartile range. So quartile 3 minus quartile 1, 56 minus 22 is equal to 34. So for this example, my interquartile range is going to be 34. Now, when you are calculating quartile 1 and quartile 3, if those quartiles were in between 2 numbers, what you would do to get your quartile value would be to add those 2 numbers together, divide them by 2, similar to what we do when we're calculating the median. So there are a couple of examples of how do we calculate the range in the interquartile range when we're looking at measures of spread of a data set.